All right, guys, this is going to be a continuation of the last video that you watched on systems of equations with three variables. So we're going to continue talking about what happens when you end up having potentially inconsistent or no solution for these systems. So we didn't do any of those with the last video. We focused on when you found the intersection of the three planes was a point, or you could have intersection being a line. All right, so the idea of having one or two free variables, which we mentioned in the last video. So in this video, we're going to focus on what happens when you have contradictions when you're doing your work, false statements, and what that means. All right, so ultimately what you'll see is that with these systems, we're not going to have a single point or even any solution. You might have parallel planes. It might be all three are parallel to each other, or just two are parallel to each other. But all that matters is if you have something happen while you're doing this, like a contradiction, you're going to have no solution. That's kind of the main thing. All right, so I'm going to do 4 examples in this video. So example 7, all right? So the first thing I'm going to do is I'm going to solve for z like I did in the last one. Again, you can choose any variables here. Like I notice x and negative x for the first and third equation. You could eliminate those immediately. It's up to you. I'm going to stick with this process here. So copying down my first 2 equations. And when I do that, I notice I want to multiply the first equation by 2 so I can get the same values for my coefficients in front of z. Oops, I should probably actually multiply all of them. My bad, sorry guys. So 2x plus 4y minus 2z equals 6. That's my first one. Write down the second one. I didn't change that. And what you should notice is that when I subtract this, I'm going to get 0 equals 0. So that means my first equation and my second equation are actually, they are the same plane. All right, they're right on top of each other. Let's see what happens when I do the next one. All right, so I'm going to have solve for z, and this is going to be equations 2 and 3. So 2x plus 4y minus 2z equals 6. Copy down the third one. Just like before, I'm going to multiply one of these by 2. This time I'm actually going to get, opposites for my coefficients with z, so I will be adding to eliminate. So negative 2x minus 4y plus 2z equals 6. So I'm going to add to eliminate. And you'll notice everything on the left side of the equation becomes 0. But on the right side, it's 12. So this is a false statement. All right, so what this means is that these planes are actually parallel to each other. So we said this earlier, but the first two were actually the same plane right on top of each other. And the third one here with the second one, they're actually parallel, so they'll never touch. So the idea here is that because we are unable to continue the actual problem, all right, there's not going to be a solution or an intersection with all 3 planes. Yes, 2 of the planes are the same, they're right on top of each other, but we need all 3 to intersect at some point or line or plane. And that doesn't happen here, so we're going to write no solution. This is an inconsistent system. All right, so that is example 7. All right, let's move on to example 8. Okay, so same thing. Start with number 1, where I'm going to solve for z using the first 2 equations. So 3x minus y plus 5z equals 2. Copy down the second one. I'm going to multiply my second equation by 5 to get opposites there. So 3x minus y plus 5z equals 2. 15x plus 5y minus 5z equals negative 20. And I'm going to add to eliminate, which is going to give me 18x plus 4y, that becomes 0 for my z's, equals negative 18. All right, so far so good. Let's go to the second one. Solve for z again, but this time with the second and third equations. So 3x plus y minus z equals negative 4. Copy down my third equation. I'm going to multiply the first equation by 10 That will allow me to eliminate with addition. So 30x plus 10y minus 10z equals negative 40. Copy down the second one. And I'm going to add to eliminate. So that's 36x plus 8y equals negative 42. All right. And then I'm going to put these together like you did before. So put it together, 18x plus 4y equals negative 18. 36x plus 8y equals negative 42. And your choice, I'm going to multiply the top one by 2. All right, so that will give me 18x. Oh, nope, let's multiply it down. Sorry about that. 36x plus 8y equals negative 36. Copy down the second one. And I'm going to subtract because 36x and 36x are the same. But you should notice is that I get 0 equals, and that's going to be 6, I believe, which is a false statement. All right, so in this case, all right, we can stop working because we're not going to have any way for these three planes to intersect at a point, a line, or a plane. All right, so because even though I was able to get a little farther in this one, all right, I still wasn't able to continue after finding those two equations after I eliminated z. So I'm going to stop and write no solution. This is an inconsistent system. Okay? All right, let's do another one. Two more. Example 9. All right, so solve for z. We have negative, using the first two, negative 4x plus 6y minus 2z equals 1. Copy down the second one. I'm going to multiply the second equation by 2, which will give me opposites. So 4x minus 6y plus 2z equals negative 8. And I'm going to go ahead and add. And when I eliminate, everything becomes 0 on the left side, except on the right side it becomes negative 7. All right, so that's a false statement. All right, so the idea here is that when we do these, right, what you'll notice is that we can go ahead and stop working. If you want to do the next step, solve for z with the next two equations, you can. But these first two planes that I just found are parallel. They never intersect. So if those two planes are never going to intersect, then all three of these can never possibly intersect. But I'll show you the work for the next two. Okay, so that's the second equation, right? The last equation. I'm going to multiply the top by 3. So 6x minus 9y plus 3z equals negative 12. Copy the last equation. And I am going to subtract to eliminate z. And again, shouldn't be surprised, we're going to get 0 equals negative 17, which is another false statement. So the second one and the third one are also parallel to each other. So again, these will never intersect. So we're going to write no solution. It's an inconsistent system, right? Consistent would mean there is a solution. Inconsistent means there's not. Okay, let's do one more. All right, so one more here. Starting with the first two, solving for z, I'm going to do 5x minus 3y plus z equals 7. This is kind of nice because you'll notice that if I'm using this to solve for z, or excuse me, I should say, I keep saying solve for z. I'm going to go back and change that. I apologize. If you've already stopped watching, my bad, but I'm going to go back and write eliminate z. That's my bad. All right, so let's go and add. All right, because I want to eliminate z. There we go, not solve for z. So eliminate, I'm going to get 2x minus y equals 3. Let's write this one correctly. Eliminate z. There we go. All right, so I'm going to write the second two, negative 3x plus 2y minus z equals negative 4. Write down the last one. I'm going to multiply that top one by 2 to get opposites so I can eliminate. So negative 6x plus 4y minus 2z equals negative 8. copy the second one down, and let's add to eliminate. So I get 2x minus y equals 4. Put these together, you can probably already tell what's happening. And I can actually subtract to eliminate x and y. They both become 0. And 3 minus 4 is -1. So what we did is similar to the example 8. When we eliminated and we got our two separate equations with x and y, we put them together and realized that that became a false statement. So again, we're going to stop working and write no solution. This system is inconsistent. All right, so that's it for this. I'm going to go back and I'm going to change all of these to eliminate, so I apologize for that. But if you want to stop watching, you can. I'm just changing these to eliminate before I finish the video. Don't forget, when you're practicing these, right, they're not always going to be like this. So make sure you know how to do ones that actually do have solutions, right? Like we did in the last video. If you skipped that last video, don't forget to go back and take a look, because, you know, on our test, we're definitely going to have some that have solutions, right? Sometimes the solution is a point, an x, y, and z point. Sometimes the solution is going to have one free variable. So all of your x, y, and z will be in terms of x, or you might even have two free variables where you have x and y, and then your z is in terms of x and y. So if that doesn't make sense, please, please, please go watch that video and try the homework, all right? Good luck.